Hello everyone, my name is Thomas Kim. Today is January 27th, 2019. This is my 32nd episode about template metaprogramming. In this session, we will learn how to use rvalue reference correctly. If you haven't watched my previous episode, template metaprogramming 31st episode, please click this link. And please watch this series of videos especially about template metaprogramming 31st type decay and perfect forwarding. Also about template metaprogramming 30 auto and auto reference these videos. Because this session continues from my previous video, you probably have to watch my previous video to understand this session. Click this link. We will be downloading a source code from our previous session, then show in folder, unzip it, please copy this file, type name.h, copy, and paste it to your working folder. I will create a folder here, perfect forwarding tutorial, and double click this folder, copy this folder path, start Visual Studio Code, then in Visual Studio Code file, open folder, paste the folder path, then select folder, then create a folder 01 rvalue semantic. Create a folder like this. From the download folder, copy this file, copy in our working folder again, and paste it here. Then this file will be created. Now in this folder we will create a file rvalue.cpp. Ctrl V F11. Include IO stream, include vector, include talk play fun, type name h, void test rvalue basic, int main test rvalue basic. My name is Thomas Kim. My real name is Kim Chang-hee. I have another name, Tom the cat. Both Thomas Kim and Tom the cat are alias for Kim Chang-hee. Each alias has its intended usage. Both rvalue reference and rvalue reference are alias for another type. Let's understand that both rvalue reference and rvalue reference are alias for another type. Okay. int a, int, this is rvalue reference lr a, int, this is rvalue reference rr a. this does not work. This does not work. You cannot assign L value or R value reference to another R value reference without typecast. So it does not work. Okay, then we will display std cout. This is address of A, std, and there std cout lr, the address of R, lr std, and there std cout rr std, and there. First, it does not compile because this is L value and we cannot assign L value to R value reference. I start a command prompt. I will change the default folder. This folder, copy, right click your command prompt, properties, then copy and paste here, click OK. Then start the command prompt once again. Then we are in this folder. Now we are testing. Sorry, I think I made Ctrl B. I have to copy to this folder. I copied, then here CL EHSC Microsoft Compiler std C++17 R value cpp fe mexe. It does not compile. So at this line it is causing syntax error here. Okay, 27. We have to typecast to R value reference like this. Then it should compile. Okay, now it works. Ctrl M. Please note that this is L value, integer A value. This is address is AD0. This is L value reference. Also refers to the same place. It refers to the same object A. Also this is R value. The address is the same. So LR, L value reference, R value reference, both are alias for A. Okay, I hope you understand this point. Also another thing very important is that you cannot assign L value or R value reference to another R value reference without typecast. I will explain this example more correctly. int R1. Okay, this is we assigned R value to R1. int R2 R1. It does not work. We cannot assign a R value reference to another R value reference. So this does not work without typecasting. Okay, I will try once again, compile once again. So it does not work. 37, this causes the error. We need typecasting like this, int rvalue reference. We need typecasting without typecast. Okay, now we compile it. I copy these two lines once again. Sorry. Then this would be R1. This is R2 and R2. Okay, so we build M. So please note that R1, R2 are pointing the same memory place, 34. Okay, so rvalue reference is also an alias as rvalue reference. Understanding this concept is very important. Another thing you should keep in mind is that please note that this is local variable A, this is rvalue. The address of A is 30, the address of R1 is 34. Okay, just 4 byte more address, higher address. Okay, so both this is local variable A is local variable. This 5 rvalue reference, this 5 pure rvalue is also allocated on the stack, in the same stack space. Okay, so this function, this test rvalue basic goes off the block, this goes off this block, then this rvalue 1 also gets destroyed. Its lifetime ends in this block. Control B, F11. Okay, now let's learn how to use rvalue reference properly. Void test rvalue usage like this. rvalue reference is used to recycle rvalue or x value. So to understand this concept, I will create a vector. I will name it using, I will say vctr t std vector int. I defined a type alias vector for std vector address vector class. Then I create a function void print address constant vctrt. Then we got a vector. Please note that this is just an alias. Then we print, I need to include assert here, include C assert like this. Then here assert B empty. It should not be empty to try to test like this. It should not be empty. Here std cout is just to say b 0. It prints out the address of the first element of the vector. Print out the address of the first element of a vector like this. Then we create a function, a vector here, std, I say vctr t v1 we create a function here, vctr t make vector vctr like this, then template type name type name types like this, type v1 types a1 argument 1, then here args like this. I put it wrong place, copy this, paste it here. I create vctr t d like this, a1, and it should be args. This is periodic template. I think I explained about periodic template in some other videos. Then we print the first element of a address like this, print address. I will make changes, constant character message, then msg. I modified like this, then v in make vctr v. We are printing the address of v here, the internal address, element address, internal element address like this. Then we make vector like this, make vctr 1 2 3 4 5. Okay, now we display this address of v1, print address in. I copy this function like this. I have to remove this part. Then here v1 like this. I would say this is v like this, v's address, and here v1's address like this. Then we call this function now we are calling this function. Please note that we are calling this function. We pass 5 integers to this function, this make vector. Then it creates a vector, local variable vector. This is local vector. Then we return v. We return this local variable. We are returning local variable. Then we catch the local variable. Then we initialize this v1 and we print out address. Okay, so this address and this address. Control F11. Then here dir. Now this time we will try to use GNU compiler, G++, SDD, C++ 17, rvalue, cpp, gexe. Okay, G. Now read this message carefully. V's address is this local variable's address, B. its first element address. Okay, we are calling this function the first element address is 5110. In this case, in this v1's address is also 5110, exactly the same. How? We surely copied the address here. This is because move constructor is working. In this case, vector std vector class, this class std vector class defines move constructor. Okay, this is local. When the local variable is this is r value, this return value is r value is returned, then it moves the address, internal address. v1's internal address is moved from here to here. So the first element's address does not change because it moved. So to use efficiently modern C++ compiler, we have to define move constructor. And we will use this mechanism in our software development. Now let's see how we can take advantage of rvalue reference. Here I will create two vector addition, vctr t. It returns rvalue reference like this, operator plus vctr t rvalue reference v1, vctr constant vctr t v2. Please note that in this case v1 is rvalue reference, v2 is lvalue reference. So here we first test the size is identical, size v1 size, then assert size equals v2 size. Okay, the size should be identical. Then we add like this, for size ti equals 0, I less than size plus I. Then we do like this, v1 I plus v2 I. Then we return this v1, return v1. We cannot pass like this. We have to typecast vctr t rvalue reference. Okay, this is rvalue reference. At the beginning section of this video, I said we cannot assign a rvalue reference to another rvalue reference. I say we cannot assign an lvalue or a rvalue reference to another rvalue reference. In this case, this v1 is passed as rvalue reference, but it is actually lvalue. About this concept I explained in my previous video. I will give you the link shortly. We have to typecast to return rvalue reference like this. Okay, this is actually more correctly, this is x value or expiring r value. Okay, I also explained about expiring r value in my previous video. Then I copied the same function. I copied again. Now this time we changed the order like this. Now this is lvalue reference. Then I will make it rvalue reference on the right hand side like this. Now we change the role. This is 2, this is 1, like this. Then we move R2. Okay, so we are recycling this V1. We are recycling rvalue reference V1 in this case. In this function, we are recycling rvalue reference v2. Okay, so we are recycling v2, and we define another function like this. Now we are returning local variable v1 constant v2. Now in this case, both v1 and v2 are rvalue reference, so we cannot use like this way. Instead we do like this, or we are creating an instance. We are creating an instance like this. Then here we say v, and we reserve memory. We can reserve memory like this. V reserve size. We reserve memory in ahead. Then here v in place back. In place back v1 I plus v2 I. Okay, we add two vectors, then I have to say plus like this. Then we pass this v. We have to pass v. We are returning now. Here return local variable. Please note that we are displaying the local variable's address like this. First element of this v, print address v local v's first element address, then v. Okay, so we overloaded the three function. This is one function. The first element is rvalue, another second one is rvalue reference, and this is the role is swapped. This is rvalue reference, this is rvalue reference, and in this case both are rvalue reference. Only this creates instance. We create instance once. We create an instance using copy constructor. Just once, copy constructor over vector v1. Then we reserve memory of v1. Then we fill the address. Now we can use these three functions like this. Here, void recycle rvalue reference like this. vctr v, we create one instance of v. I say v1, make vector 1 2 3 4 5. We make another one, vctr t v2. We make two instance, make vctr. Now this time 5 4 3 2 1. Then we add these vectors together like this, or it should be t. We are making another vector, third vector v3. Please note that we are adding v1, v2, we add up, then we display print address v3's first element address, like this. Then v3, then we call this function, let's examine our code once again. In this make vector function, I will disable this part, and in this function I made a silly mistake. I fixed like this. This is b1, and in this function b2, it should also be fixed like this. And let's see, I made silly mistake. So we have to create empty vector like this. Then we reserve memory. Then we push back. And I made a silly mistake here. It should be b1 like this. I fixed. Then scroll down. I will make another vector here. I copied, pasted, and I will make it b0. I will make it 4. Then we display the result for order b3 std cout b, like this. Copy, paste, std, and there. Like this. Now let's build. We are using GNU compiler. Okay, G. Please note that this local v's first address, this message is displayed once, and let's examine here. This local v's element address v, this message is displayed once. It means this function is called once. This function is called once, and this local variable is created once, and this local variable is recycled. I think the result is wrong. We will add v0 like this. Then we call this is once, then the result will be added twice, so it will call twice. Let's build once again. G. So local v first element, this message is displayed once, and this address is a0, first element a0. So this is created once, this local variable is created once, but it is recycled again and again. Then finally this calculated this address, this local variable's address is assigned to v3. In this case it is used the move constructor. So we created a local variable just once for this addition, then we recycled the local variable, in this case twice. Once, this is once, then twice, to calculate v2. So we add v0 arbitrarily, v0, okay. Then if we run it, we rebuild and run it again. We calculated 1 addition 2, 3, 4, 5 times, but local variable is created just once. We recycle the R value again and again using this mechanism. Okay, and once created local variable, this local variable, this v, is again copied to this. It is not copied, it is moved to v3. So we created a local variable once, then we moved around this local variable as R value reference, also here R value reference, until the calculation ends. Then when the calculation is done, then we move that local variable's memory to v3. This is very efficient way to recycle local variable as R value reference. Some of you might feel uncomfortable about this approach since we created a local variable here and then we pass around this local variable as R value reference and also R value reference until the calculation ends. In this case, until the calculation ends, you might feel uncomfortable if it gets destroyed in between. C++ language standard promises that R value, this local variable created in between these operations, persist until this operation ends. I mean, this local variable created in between these operations will persist until this expression ends. So when the expression ends, we can successfully move the contents of this v, this local variable, to this v3. So you can rely on C++ standard promise. Also, another thing, one drawback of this approach is that this is one operator plus, there is another operator plus, there is another operator plus. We actually defined 3 operators for the same operation. In my next video, I will explain how to merge all these functions, 3 functions, into a single template function. This is called static polymorphism. Please subscribe to my YouTube channel. Don't fail to watch my next video about static polymorphism. Thank you for watching.